Assalamualaikum and hi. This video will explain about the simulation of our group project. For the first question, we are given the natural response of parallel RLC circuit, and we are required to solve three different types of natural response. For the first response, it is under damped cases.
To find the initial condition of the circuit, we are using the Orcads software. So the value of R2 in this case is 8 ohm, and we can find the initial condition by taking the voltage and current plot in the circuit, and we will run the circuit. So this is the result of showing the graph of underdamped cases. Next, we are using the MatLab coding for finding the values. So first, we will set the initial conditions of each component in the command window. Then, we will find the initial condition of the voltage and current across the capacitor and inductor. Then we will find the value of the damping coefficient, natural frequency, and then resonant frequency of the cases. Then we will find the coefficients of the value of A1 and A2. And lastly, we will put the equations of the underdamped cases. And we will run the graph. And this is the graph shown in the MatLab, and we can see that the graph in Orcad and the MatLab is basically the same.
For the next case, we change the value of R2 to 1 ohm to get the critically damped case for the natural response.
Next, we find the initial conditions by changing the value of R2 to 1 ohm, and we will run the circuit. The initial condition will be shown. In the coding, we change the value of R2 to 1 ohm, and the others is the same. And we run the circuit. The critically damped case graph will be shown.
For the third cases, which is the overdamped cases, we change the value of R2 to 0.9 ohm.
We change the value of R2 to 0.9 ohm to get the overdamped cases. So we run the circuit, and the value of voltage and current will be shown for each component. In the MatLab, we change the value of R2 to 0.9 ohm, and we run the circuit, and this is the result of the overdamped cases. For question 3, we are required to design a smoothing circuit by using simple RLC circuit. So we are using 1 ohm resistor, 1 Henry inductor and 1 farad capacitor for our circuit. We are doing the simulation by using the Simulink. So first, we will create the signals by using the step input, and then we add up the 3 signals by using the add up blocks, and we do the signal conversion and transfer the signals to the control voltage source and to the circuit. So lastly, we will do the voltage measurement across the capacitor and connect it to the time scope, which will display the graph. Then we will run the simulation. So this is the graph of showing the result. The yellow graph is the step input and the blue graph is the graph showing the voltage across the capacitor.
We change the input to RAM input and run the simulation. This is the graph for RAM input and the voltage across the capacitor. Next, we will use the discrete impulse for our input and run the circuit. This is the result of discrete impulse and the voltage across the capacitor.